So one of the key things that I expect from you tonight is to ask a lot of questions. This is your time to ask questions, find out a lot of information about our program and about our college. You'll have some panels and you'll have some good opportunities to find things out. I just got from a meeting, came from a meeting where, again, they showed some age demographic data of the Hanford site. And we've been talking about this for years, but it's quite true that in a lot of cases, we have a potential crisis on our hands. The average age in a lot of trades is around 54, 55. And they'll be retiring soon. And we will need people that are smart, that aren't afraid of math, that can operate in teams. And the bottom line thing that's important is safety and operating safely. And those are things you're going to see throughout our program, and any employer you talk to is the importance of safety. Okay. So I hope you have a good night tonight and cram your head full of information. And if you have questions after tonight, there's always information sessions that we offer, or you can always contact our staff to get more information. Thanks.
Thanks, Derek. Well, I want to also welcome you here tonight. It's so awesome to see so many faces, especially young faces, some of you high school students that decided to come out. My name is Kelsey Myers, and I'm the director of our Nuclear Technology program. And I'm going to spend a few minutes with you this evening talking about our program, letting you know what it would be like to be a student here. And then we're going to open it up, and we're going to have some of our instructors talk with you about what it's like to be in this profession. And you're also going to hear from one of our current second-year students who's going to let you know what it's really like to be in this program. So with that, I'm going to dim the lights a little bit so you can see the presentation. And thanks, Don. I have a microphone. I can't move too far. If there are any questions that you have as we go, don't hesitate to raise your hand and I can take those. There'll also be some time at the end. All right. So you met Derek and I, but I'd like to also introduce to you Dawn Alford, who is our Outreach and Retention Specialist. All the beautiful signs that you see, Dawn has helped market our program very well. I'm very grateful to have her on our staff. We also have Stacy Presnell. You can stand up, Stacy. And Stacy actually works at Energy Northwest. What's unique about our program is that we are in a partnership, Columbia Basin College is with Energy Northwest. We have a lot of other partnerships as well, but part of what we are involved in is called the National Uniform Curriculum Program. And what that means is that us and 37 other community colleges partner with a local industry or utility to make these programs run. And part of the reason is as Derek was talking about, there's a gap happening, and we've got a lot of people who are ready to retire or almost ready to retire, but there's not enough people to fill that gap. And so part of this is actually driven by the industry to ensure that we are going to have knowledgeable workers that are ready to enter the plants. What's unique about our area is that we also have Hanford. And so we have a lot of other partnerships, as Derek mentioned, CH2M Hill, Arriva, Washington River Protection Solutions, that are also in this. And I can't tell you how wonderful it is to be part of a program with so many people that are passionate about this and want to make this happen. And tonight we have a few of those people here who have given up their evening to be with you tonight. They also teach at night in the program and work a full-day job. So when you do enter our program, I think you'll find that this is somewhat unique in that we really do have a good partnership and a lot of support. All right, so a little bit about our program. We offer an Associate of Applied Science in Nuclear Technology. Right now we have 3 degree offerings. You can enter as an Instrumentation and Control Technician. You can enter as a Radiation Protection Technician or as a non-licensed Operator Technician. Now, the way that this works is that these programs are going to come and go as the industry needs them. So these are the current ones. We are in conversations about adding some other ones, maybe electrical, mechanical. So we're kind of basically working with the industry to make sure that those that we're producing, we're not going to oversaturate the market, but we're also filling the need that they have. As I mentioned earlier, we're part of the National Uniform Curriculum Program. The other cool part about that for our students is that we can offer national certificates on top of getting your degree. So students who finish their degree here at CBC have the opportunity to also earn their national certificate. What does that do for you? It allows you to be eligible to work at other power plants across the nation. And we are currently, I told you that there's 37 other community colleges that are partnering with local industry. Well, we're one of 7 that can only offer those national certs right now. We're very proud of that. It took a lot of work to get where we're at, but that's in part of the people that are helping support this program. Part of the National Uniform Curriculum Program requires that we all are teaching the same objectives, so that when you go out to work in the industry, you're going to have the basic knowledge that you need to work at a power plant. Doesn't mean you're going to have the plant specific, because every plant is a little bit different, and you'll have to learn that when you get there. But you'll be ready to work at Energy Northwest and any other plants that you might be interested in. You'll hear about this program. You know, there's a local need, but you also have the opportunity to travel. So some of you young people who might be interested in being able to see, you know, the nation, there are a lot of different places you can go, and actually the world. The way that our program works is that we're a cohort model. So we accept students once a year. We recently accepted our cohort 3, so our third group of students, in fall of 2011. And right now, we're promoting our program for fall 2012. Our applications, you'll find, are going to be due April 9th, and I'll talk a little bit more about how we accept our students into the program. We have a few students, if you guys could stand up and raise your hand, that'll be graduating. Go ahead. This spring or summer. And yes, they do deserve a round of applause. They've worked really hard. And I told them not to bother me while I was up here presenting. They're doing good so far. But I would encourage you to talk with them. They can give you a really good picture of what's going on for them in this program and all the hard work that they're having to give to make it happen for them. And like I mentioned, we started our third group of students, which you'll be able to meet. They did student projects out in the hallway. Our program is run in the evenings, and so there's some good things that come with that. It allows you, if you are somebody that needs to work, you can work during the day. If you've got a family, you can at least see them sometimes during the day. But part of the problem is, or not problem, but part of the really good thing is that we have experienced instructors who are committed in the evenings. So they work really early in the morning. A lot of them get there at 6 or 7, I think. And then they're teaching in this program, Jamie, you get done at 10 at night? So you're getting people who are working currently in the field and have worked in the positions that you're going to be getting your degrees in. So typically, just as you're planning ahead, you want to think about, you know, reserving your time Monday through Friday from 5 p.m. to 10 p.m. That's what your commitment will be. There are occasional weekends where you'll be here on Saturdays doing some lab work. So I just like to throw that out there so you're aware of what our program, kind of how it runs. It's a little bit different than some of the other programs here at Columbia Basin College. I've mentioned many times we have experienced instructors. You'll get a chance to meet them here in a few minutes. The last thing is we are a competitive admissions process, meaning that you have to turn in a separate application to enter our program. And we're looking for students who meet certain qualifications, and I'll go over those in just a minute. Okay, so just a heads up, for those of you that are high school seniors, or for those of you here tonight that are beyond high school, you will be eligible to apply for our program. Those applications are due April 9th. You can get our application from our website, which that website will be up at the very end, or we have hard copies of the applications out on our information table. Right now, we're taking applications for, as I mentioned, instrumentation and control, radiation protection, and non-licensed operator. Here's what you need to know, the bare minimum to apply. As of entering fall quarter of 2012, you must be eligible to take Math 141, which is pre-calculus, and English 101. Okay, you have to be ready for those levels. So if you place below that on the compass, which I'll talk about here in a second, then you need to make sure that you take some classes. For those of you that are high school seniors, you'll need to take a class in the summer. You also are required to do a personal essay and have 2 letters of recommendation. And all that information, as well as some other things that are required of you, will be in the application. All right, so for those of you that will be thinking about applying for our program, this is a list of the general education requirements. And what this is this is a list of the classes you can start taking right now before you're in our program. And we actually highly encourage you to take as many of these as you can. The more you have done, the easier the program is going to be in terms of workload for you. All this information can be found on our degree information, and if you look on the different degrees for each of our options, you'll notice a section that says general education requirements, and that's where you can get the list of those classes. All right, how many freshmen, sophomores, and juniors do I have here tonight? All right, this slide's for you. So, guess what? You need to enroll and complete 4 years of math. Okay, it's really, really important that you do that. That's going to help you to enroll in some of these programs like the Nuclear Technology program. And you know what else? You got to take 4 years of science. And those science classes should include chemistry and physics. I know I said it. Now, the cool thing is that once you really dive into the science, which I know some of you are from a high school science classroom, you'll find that it's actually quite fun. And you can see the possibilities that different careers can open up to you, one of them being this program. And of course, do your very best in all of your classes, not just your science and math. All right, so for those of you that are high school seniors and or brand new students to our program, I just want to walk through the quick steps of getting started. You'll need to first submit a college application, which you can get in our admissions office or online. I believe you still have to download it and send it in. I don't think you can fill it out online yet. And pay the $28.30 application fee. You will then schedule to take the Compass. And the Compass is an assessment looking at your reading, writing, and math skills. And what that's going to do is going to let you know where you place based on those skills. That's where the information is really important for you to look at, because that's going to let you know if you're eligible to apply for our program this year or if you need to take a year and build your math and writing skills. If you have questions about where you place and how those apply, you can contact Dawn and I at any time. When you're done with that, you'll complete what they call SOAR. It's a new student orientation. It's an online process. And then you will either take the general education courses, depending on where you place, or you'll apply to our program. For anybody who's transferring in, coming from another college, you'll need to have your official college transcripts sent. They need to be sealed and not broken and submitted to our admissions office. And for those of you that are transferring in, I'm happy to talk with you after this session, a little more complicated. All right, so the way that our selection process works once you apply, we take a look at your application. We look at how many of those general education courses you completed. So we look at your English, your math, all those classes that are listed, and we see how many you've completed. You get points for completion. Okay, so the more classes you have, the more points you're gonna get. We look at special considerations. You'll see in the application packet, there's some other things that you can include in your packet, which include completing the FAFSA. And that is something that we encourage you to do, so that way you can find out if you're eligible for any financial aid. And the last thing, so after we do those 2 things, we give you a score, and based on that score, we invite the top students to come in for a group interview. And based on that, then we make our selection. So we review and score your applications in April and May, and then we bring you in for interviews around May or June and make our final selection around June or July. And the reason it's kind of broad is it depends on a lot of different things when the industry people are available to do the interviews and how many applications we get, how long it will take us to get through all those applications. You're probably wondering, well, how many people do you accept? The way that is, since we're part of this national program, we can accept no more than 15 students per discipline. Right now, we're accepting usually anywhere from 8 to about 12 per discipline. So discipline meaning radiation protection, INC, non-licensed operator. Okay, this is just a quick overview. Once you're accepted into the program, you will be required to do what we call a bridge program. For those of you that have not completed Pre-Calculus 1, you'll have the opportunity to be with us on campus for 2 weeks prior to the quarter, doing a refresher for math. What we find is that a lot of students need a quick refresher to help them do well in their Pre-Calculus 1 course. And so we've got an awesome instructor here at CBC who's been helping us with that. So you'll be here on campus for about 3 hours, I think, for 2 weeks, but it will help you to be more successful in your math class. And then the other thing is we have first year introduction, which is tailored specifically for the nuclear technology students. And you will get to know each other because it is a cohort model, so you kind of become a family because you go through this entire process together. So you'll get to meet each other, and we do bring in a lot of industry people to talk with you a little bit more in depth about the industry and what you can expect. All right, so I want to bring up program cost, and part of the reason is that we are not a state-funded program, which means that we don't receive any state dollars for the students that are in our program. Therefore, we consider ourselves self-supported. That means that you pay the full cost of tuition. This year, you can see that the cost is $200 per quarter for a lab fee, $120 per credit. That will increase next year. I did get confirmation today that that will increase. As to how much, I'm still working on what that's going to be. And that doesn't include any of your living or books, all that good stuff. So I'd like to throw this out there early so you can plan for our program, which is why it's really, really important that you apply for the FAFSA. And the reason is that even if you don't get grant, you may need a loan to assist you with this program, and that's part of the loan process as well. And so a lot of students don't apply for that thinking, well, I'm not going to get any grant money, but you might need that loan. And for those of you that don't know, financial aid can take a long time to process, so it's important for you to apply today. I think the deadline is somewhere in April for priority. It's important for you to do that as part of your application process. And that goes for any of you going to college in the near future. You need to apply for financial aid every single year. In January, when you do your taxes or you get your W-2s or your parents do, you need to apply for financial aid. So then we'll follow up with a little paying for college. Unfortunately, the foundation scholarship due date is passed, but for those of you that are going to be seniors next year, this is something you'll want to keep in mind. Every February 21st, our foundation scholarship is due, and if you apply for that, it opens you up to many, many different scholarships, hundreds of scholarships that the foundation offers. So it's a really simple way for you to get money. Just general other scholarships, you can visit our financial aid website as well as your local high school for other scholarships that might be available to you. This last year, we were not able to offer a scholarship from the NRC. They did away with their funding. However, this year, we understand that their funding is back, and so we're just waiting for some final information. We did apply, and we're hoping that we'll be getting that scholarship again. So I know that the guys in the back are going, shoot, some of them got it the first year that we had it. So I just want to let you know that anything like that that happens, we'll definitely keep you posted. All right, so I've talked a lot at you. What I'd like to do is open it up for any questions regarding the program. I know you have questions about what does it mean to be an INC tech, what does it mean to be a radiation protection, and I have a lot of experts up here that are going to answer those questions for you. But any questions about applying to the program, how the program is set up that I can answer? Okay, do we need to use the mic? If you could just repeat the question. Okay, what's your question?
If you passed the compass in the past, do you have to retake it before you apply?
So the question is, if you've already taken the compass, do you need to retake the compass? No. Did you take it at CBC? Then no, you do not need to take the compass over again if you place at college level in all three of those areas. Good question. Anyone else? Well, I'm sure you do have a question. I will be around afterwards. So will Dawn. So will the other students, I'm sure. Feel free to ask us some questions. Appreciate your attention tonight. So I'm going to hand this over to Dawn, I believe, who's going to get our panel set up.
All right, if I can have the panel come on up. Okay, I want to welcome you again to the Nuclear Technology Open House and Career Fair. What you have in front of you right here is years and years of experience in the nuclear technology field. You'll get to know them in a minute. And at the very end there's Jason, and he is one of our nuclear technology students, because who better to tell you about the program, who's really in it, than one of our students. So first, I'd like to start off with passing the mic down, and if you guys could please give us a brief introduction of yourself, please.
Hi, my name is Stacy Presnell. I work at Energy Northwest. I currently manage the nuclear technology program with Kelsey and Dawn. Previously, before that, I was a RPT tech for about 11 years, and I've worked at a lot of different nuclear power plants around the country.
Good evening. My name's Jamie Morris. I teach in the non-licensed operator program currently. I've got about 30 years of experience in the DOE environment. I worked 13 years at Savannah River site in a nuclear reactor back when we were still running production reactors. Transferred here with Westinghouse in 1994 and have held various operational and training capacities on the Hanford site. I started out, interestingly enough, as an operator after I completed an operator training program way back in 1981. So I'm kind of giving my age away, but that's okay. You can look at the gray hair and tell how old I am anyway.
I'm Rob Lowe, INC instructor. Been in instrumentation for 28 years. Currently work at the control room simulation at Energy Northwest, and been there for 2 years. Been in the industry for 28, and Boise Cascade for 20, and Westinghouse for 5 years before that. Nuclear Fuels Division, and that's on this first.
Just to track this one down. Okay. I think we're running out of cord this way.
Good evening. My name is Bobby McDaniel. I'm the one of the radiation protection technician instructors. Currently work as a health physicist at the Hammer Training Facility for the Hanford site. I too have gray hair like Jamie, and I'm going to date myself even more. I joined the Navy in 1972, signing up for the nuclear power program, retired from that program, and have been involved in some form of health physics ever since then. Currently a registered radiation protection technologist through the National Registry of Radiation Protection Technologists, and this close to being able to sit the exam for certified health physicist through the American Board of Health Physics. And if you turn the lights off, I don't glow in the dark, so you guys can certainly pursue this field if you want to.
Hi everyone, my name is Sandy Bradford. I am a senior technical instructor with Washington River Protection Solutions. I began my career 30 plus years ago as an operator, and I don't have gray hair. I'm going to keep it that way. I teach the nuclear facility component course here. I've been here for about 3 years now with the program, and it's a fantastic program. So with that, I'll pass it to Jason.
Hi, I'm Jason Deering. I have been out here at CBC for about 2.5 years. I will be graduating from the nuclear technology program in June, and I am in the instrumentation and control program.
Okay, so let's start with the questions, right? So what is a radiation protection technician? I'm going to ask that to Stacy.
Well, that's a pretty wide open question. The day in the life of an RP tech is pretty varied. So I'll try and give you a small of a perception as I can. But basically, you're a safety officer, and your job is to know what the radiological conditions are using instrumentation that reads radiation and contamination. And based on what the instrumentation gives you, you take that data and you control areas with postings and barriers. You also utilize tools like radiation work permits, processes, and procedures. So you work pretty closely with people. You need to like to work with people. You educate people as to the radiological conditions of where they're going to be working at inside of a nuclear facility, or maybe out somewhere like at Hanford where they're cleaning up radiological waste. So there's a lot of different applications that radiation protection technicians work. So you also will be working really closely with people doing various different jobs, whether they're working in the Corps, when they have the refueling pool filled up with water, and they're actually taking out spent fuel and putting in new fuel, and they're taking things in and out of the water. So that would be some kind of a job where it's constant job coverage. There are those types of jobs. There are jobs where you'll just go out and you'll do surveys of areas around the power plant so that you can post them so that as people are going through and doing their jobs, they know what the dose rates are in those areas so that they can shorten their time there or make sure that they should be in that area. So there's a lot of different things. I probably should get a picture of what some of these areas look like to help give somebody a better visual.
Okay, so we know what a rad tech does. Yes? Okay, great. Okay, so what does a non-licensed operator do?
Non-licensed operator really is an auxiliary operator at a nuclear power plant. They basically operate all of your what I call pumps, pipes, valves, electrical equipment, diesel, generators, a lot of the auxiliary equipment that the power plant needs. And so they basically directly support the reactor operators and the senior reactor operators in running your power plants. And so based on all of that, the generation of power, we get to flip a light switch and actually the lights come on. So non-licensed operators are a very, very important function in the nuclear industry.
Thank you, Jamie. So Rob, what does an instrument and control technician do? And I'll bring it to the back.
An INC technician takes the physics that you'll learn in class and learn how to convert that into electronic signal to the control room. And the operator can use that signal to control independent processes. And he can use that to protect the system with interlocks, alarms, and miscellaneous other systems. And a technician on a normal day would do calibrations to verify those signals are correct. They can also do install new equipment and do troubleshooting and repair. So if a piece of equipment fails, you bring it to the shop, calibrate it, or check a loop, verify everything's correct. And you could actually use it hands-on. It's more of a hands-on field. You get to use your physics, electronics, some mechanical, and it's been a good career.
Thank you. So Sandy, if I could ask, do you see any obstacles for women in nuclear? If so, how have you seen any women overcome these?
Okay. When I started my career 30 plus years ago, there were a lot of obstacles. I'm not going to sugarcoat it, ladies. It was a lot of work because there was a lot of competition and there were very few women in the industry back then. And to come in as a process operator and to have only a handful of women in a brand new course, it was like a 4-year training program of on-the-job training plus classroom, that once we got into the program, it seemed like the gentleman had a little bit of an advantage over us. So, as much as I hate to say it, back then we had to work even harder than they did. And now today, here we are 30 years later, and do you want me to tell you that it's gotten easier? I guess maybe in a way it has, but I think that's because I grew a real thick skin. I mean, when I first started out there, if somebody looked at me cross-eyed, I might cry. Okay, now if somebody looks at me cross-eyed, well, they might not want to do that. So I guess all I can say is that expect a challenge, be prepared to, you're going out there and you're working in an industry that's predominantly male. We're getting more and more women, but a lot of those women are working in support roles. we're looking for, more engineers, more lady engineers, more nuclear operators, more instrument and controls. And I think, you get into this field, you'll just do excellent as long as you're willing to put in that extra effort, because you will have to. So, and it's worth it. It's very worth it. Okay?
Thank you so much for laying that foundation, you and Stacy. I know that you were there as well. So, young ladies out there who are thinking of careers in nuclear technology, here's proof that you can do it. And we have lots of students, female students in our program right now that are doing very well. So I hope that you will join us. So I'm going to go back to Rob and ask you a question about our program. So this program provides future technicians both classroom learning as well as lab experience. Can you tell us about the hands-on experience that students gain in our labs?
Yeah, you'll take the physics that you learn in class, be able to apply it to calibrating transmitters. You take inches of water or for pressure and convert that into level transmitters, or for temperature, convert that to resistance, and be able to calibrate individual instruments. You learn how to wire instruments, how to troubleshoot instruments, use meters, calibration equipment, and there's some new smart technology that some of the newer plants will use. You use heart communications instead of analog readings. So it's a changing workplace. Instead of the analog world, it's changed to a digital world. And we work on how to hook up control loops, tune controllers, actually operate equipment, learn how to put it in manual, replace equipment while it's running without causing upset in the process, work on valves, valve positioners, and how to tune, operate, and repair various pieces of equipment.
So very hands-on. And I hope that you will all join us a little later. We have our lab that'll be open. You can actually see some of the equipment that our students are learning and how that translates onto the job. So Bobby, from an instructor's view, what are your expectations of our students as it relates to the nuclear technology field?
We want you guys to be in the classroom just exactly like what would be expected of you working out in the field. That means studying the stuff that you don't know until you come to the point to where you do know it. And I emphasize learning and not memorizing, something that you need to be able, information you need to be able to carry with you from one quarter into the next. The idea is that by the time you get to the point where Jason is here, that you can take the individual pieces and put them together and be able to see the big picture, and that requires that you be able to remember what you've been taught already. We expect that you have the attention to detail, and I'm sure everybody sitting on this table with me would stress that the biggest thing with nuclear power is attention to detail. If you're not paying attention to what you're doing, the slightest little slip up can result in shutting down the plant or doing significant damage, or worse than that, hurting somebody. So you really need to have a close attention to detail. And then I would say that safety ranks right on there. You've got to always think safety. That's got to be your top priority. Nobody's going to look out for you as well as you look out for yourself, but at the same time, you're expected to have the back of the individual that you're working with as well. You want to make sure that it's a safe environment for everybody. So I'd say those are the big things.
All right, thank you, Bobby. Jason, as a nuclear technology student, can you please give us a day in the life of an NT student?
Well, my schedule's changed a whole lot since I've been out here. I started out at CBC a year before I got into this program, getting as many general education classes out of the way so that I have a lighter load when I actually got into the program, and to improve my, how I'd score on the application. Those classes that I took, were spread out throughout the day, and I'd often have big gaps between classes, and it was a little chaotic. Once I got into the program, though, everything is in the evening, so it actually made it easier. I'd have all my classes back to back, and I didn't have the big gaps of wasted time. Normally now, though, I get up around 7 in the morning and get my kids off to school, and you know, do what I have to do throughout the day, and then I'll get here a couple hours before class starts and meet up with another, you know, other groups of students and spend that time studying. You know, since we're all in the program together, you know, we all know each other and develop friendships, and it's, you know, been really useful for studying and learning together. Let's see, what else? I have a family, and, you know, most of these classes are throughout the night, and it hasn't been as big an issue, you know, meeting all my family requirements as I initially anticipated. All the instructors out here have been, you know, really understanding, and, you know, if there's something we have to take care of, they've been very willing to work with me and make sure that I can take care of what I need to with my family. So that's been my experience out here.
All right. Now this next question is for Stacy and Jamie. What is the job outlook for the nuclear industry? So everyone listen up for this one. And please describe the salary range, benefits, and perks for nuclear technicians and other nuclear paths. Who wants to start?
Kelsey and I just were in Washington, D.C. Last week for the Nuclear Uniform Curriculum Program Summit. And a large theme of the summit from the NRC, which is the Nuclear Regulatory Commission, and INPO, the Institute of Nuclear Power Operation, was the attrition issues that the nuclear industry as a whole is facing. And they had some solid numbers. Up to 35% of the nuclear industry employees will be able to retire within the next 5 years. That's a pretty staggering number. The other issue with this is that our nuclear power plants in this country are very old. It's like trying to keep a 1950s car running on the road. And so with these older nuclear power plants, there comes a lot of really special, unique things about these power plants that these individuals who have worked at them for the last 30 years have an experience level that you just can't pick up walking in the door. And so the industry is recognizing that we have a very big need to bring in the next generation of individuals who will be safely operating our nuclear power plants. And we need to train them now and get them up to speed before the baby boomers walk out the door. Also, there's been a lot of talk about nuclear and safety, obviously with Fukushima and other things. Everybody has a cell phone pretty much in here. If they don't have it, they've got one at home, right? And everybody's got a computer. And we all operate more and more electronic things by the day. So really we don't have the technology to support our need for energy. We have to utilize nuclear power. We will be having to build more nuclear power plants. I have another solid number that I walked away from there. In the next 20 years, we will see a need to increase this by about 20%, meaning our energy use in this country. That's a big number. And so, is there a need for new students coming out of this program? Absolutely. I do have a solid median number for salary range. Starting salary ranges are between $65,000 to $71,000 a year. That's starting right, graduating from the program. Do you have anything else to add?
I think the future looks really bright for anybody that's doing this type of program. We just went through a huge hiring influx, and Ted knows this, as part of the Recovery Act out at the Hanford site. And one of the things that we realized when we got into this and we were hiring a bunch of people is the knowledge and skills that they're just not out there anymore. So completing these programs become very, very important. From a standpoint of attrition, we've talked about that. Certainly, you've got a lot of folks like me that are going to be retiring in a few years. And the average age, not just at the Hanford site, but across the nuclear industry overall, is probably an average of 54 to 55 years of age. So you got the attrition thing going on, where you're going to have a lot of people retiring, and we're going to need people that are trained, knowledgeable, and qualified to step in and fill those positions. You've also got the need for more nuclear plants, as Stacy mentioned. They've just recently been given approval to begin construction on 2 new nuclear plants at Plant Vogtle. That's in Augusta, Georgia. For those of you that don't recognize my southern drawl, I did spend some time over there. And they've also been given approval to build 2 new nuclear plants at VC Sumner, which is in Jenkinsville, South Carolina. And so those plants, when they get up and constructed, they're going to need people in it to operate a plant. What we talked about here, the rad contacts, you know, the INC techs, the operators, you have to have all of those to operate a plant. And that becomes really important. So any of these programs are really, really good. Of course, I'm partial to the non-licensed operator one because, you know, that's kind of where I came from. But the reality of it is all those positions are going to be needed in the very near future. And the nuclear industry is growing, and it's got to grow. As Stacy mentioned, the demand for power is going up. We haven't built any new nuclear plants since, what, 1996 probably, somewhere in that time frame. And so, you know, I think you're in really, really good position if you get into one of these programs and complete them and get out with your certificate. Do you want me to answer the question about the BIT plant? Also here locally, you guys have all heard about the waste treatment plant, and that's being constructed. Right now it looks like the low activity waste treatment plant is set to come online about 2019. That sounds like a long way away. However, they're going to have to start bringing people in, you know, in the next few years here and get them trained, because it's going to be a long, arduous training and qualification process to get people up to speed to be able to operate that plant. The other thing that plant will go through is a very in-depth operational readiness review. And having been through a few of those, they are very painful, and it takes a long time to get people knowledgeable, skilled, and qualified to do the things that they need to do to operate a nuclear plant. So.
Okay, so Bobby, what skills and abilities do they need to have a successful career in nuclear?
The first thing I'd like for you to think back to the slide that Kelsey put up, and although I didn't hear any vocal groans, I heard a lot of inward groans. 4 years of math, 4 years of science. I can't stress that strong enough. Basic math, not only being able to solve the problems, but also being able to think logically, to synthesize the information that you're given, to be able to formulate a solution. And once you figure out how you're going to attack the problem, then to actually be able to solve it. So can't emphasize math skills enough. The other thing is being able to look at data that you've been given and to actually interpret in your mind what that data is telling you, and then being able to formulate a plan of attack for how you're going to use that data, either what you're going to do personally or what recommendations you're going to make to your supervisors. And the last thing I think I would do is I won't use an analogy that might make it kind of easy for you to understand. You have likely heard, if your parents are anything like my parents were, continuous complaints about the position of the door. Shut the door, you're letting all the cold air out. Shut the door, you're letting all the cold air in. Well, I want you to think that air is kind of sort of like radiation, and then go clean up your room. Your room, in essence, in mom and dad's view, was contaminated until you got in and cleaned it up. So you also need to be able to think not only from the standpoint of math and that sort of thing, are you keeping the door closed where radiation is concerned, and are you keeping your clothes picked up from a contamination standpoint? So reading the instruments, and I use instruments in a different context than Rob does, but being able to read the instruments and tell what sort of dose rates am I seeing, what sort of contamination am I seeing, what sort of controls do I need to employ, or what sort of recommendations do I need to make. So that's a big thing. It really is look at what information you're being presented with, be able to synthesize it and come up with a solution of what you're going to do with the information that you're seeing. But math, math, math. ask any of those guys on the back row. They've been through my classes. See if they tell you anything about what math is like in this program. And that's not to scare you. That's to prep you in advance.
Math. One more math. Okay, so we have, as you have shown, we have some students, current nuclear technology students, and you guys are doing a great job as instructors, preparing them for careers in nuclear. But what can they do once they are on the job for advancement? And that would be for Jamie.
Wow, I'm really lucky tonight, huh? I just before I answer this question, I wanted to go back and add something to what Bobby said, because I think it's very, very important to understand that the math, you need to come with a good math background and once you get in this program. And that's the reason the prereqs and everything are set up like they are. The other part of this is, if you're going to be in the nuclear industry, you have to understand safety, you have to understand human performance improvement, you have to understand safety management systems, because what you're dealing with out there is not, I mean, it's hazardous stuff. I mean, even if you're just dealing with electrical and you're not even talking about the radiological side of it, there's a lot of industrial hazards out there at these plants. And so that's why you have to exercise, you know, the ultimate, and we incorporate some of that into the program. We talk about safety and design basis and safety basis and those types of things, because it's really important for you to understand those. And guess what? The math does help with that stuff. So it's really, really important to have that math background. Okay, I lost. What was my question now? I kind of got lost here. The non-licensed operator program is an entry-level position in the commercial nuclear power plants. So you go in as an entry-level position. Stacy mentioned the entry-level salary. That's pretty doggone good money. In fact, I'm kind of wondering what I'm doing sitting up here. But anyway, so that's the entry-level position. Then you get a chance to move to reactor operator, which is the mid-level position in a nuclear plant. And then the next is senior reactor operator. Senior reactor operators make very, very good money, and I understand they're getting some pretty good-sized bonuses right now to stay and not move around between plants. So that's kind of your advancement opportunity if you take the non-licensed operator route.
So Sandy, how did you choose your career?
Okay, let's see. Actually, my career kind of chose me. It did. When I was a student, pretty much the same age as most of you in here, my father had an injection molding plant where he made plastic parts. Now, if you've ever trimmed a plastic part all night long, pretty soon you realize this is really monotonous, and I didn't want to do that the rest of my life. So I decided, since I liked math and science, that I would try to get a job out at Hanford. Keep in mind, I knew nobody that worked out at Hanford, so it wasn't like I could pull the trump card and say, hey, can you get me on? Instead, I sat in the HR manager's office twice a week for 3 months until he hired me. And he hired me in the nuclear chemical operator program, which was the training program. And I started in there and I loved it. And 4 years later, I became a nuclear process operator and did that for about 10 years. Well, I had a tendency to get bored, so I ended up working on Johnston Island for a couple of years. And you guys know what that is? It was an island clear out in the South Pacific, about 900 miles south of Hawaii. And it was very small, very isolated, and we were destroying nerve agent. Well, what I found was that my nuclear experience also worked in that industry. And it was really exciting because when I came back to the States, I came back to Hanford. Only now I had learned much, much more about how systems actually operated and how air compressors worked and how hydraulics worked and PLCs and all of these different components that were in facilities. Well, then I determined that, gosh, I can teach these things. And I had always wanted to be a teacher. And so in a roundabout way, I went from the nuclear operator program to where I'm at now. And so it's been a great career path. And same thing can happen with all of you guys. You might get to travel just like I did. It was great.
All right. So I see a lot of high school students out here, a lot of 9th, 10th, 11th, 12th graders. Yeah? So I want to ask Jason, as now, since he is a student, looking back to when you were in high school, what do you wish you had done more of or studied more of, now looking back?
Well, the same thing everybody's been saying. Take all the math and science classes that you can. And the big one for me is I wish I would have gone straight from high school, to college. The longer you wait to go back to college, to continue your education, the harder it is to go back. So stay focused on that.
And for those who may have taken a little break, hiatus, what do you say?
Go back now, because it just gets harder.
All right. Thank you so much, panelists. So does anyone have any question for our panelists? Yes.
Of course I would. Why wouldn't I? I really am protective of our oceans. So is there any way that nuclear power can help them in any way, or is harming them more? Because
so she is sensitive about the environment, specifically the ocean, and want to know how nuclear industry affects it in a positive or negative way.
Well, that's a pretty wide spectrum question. As far as nuclear power and contaminating the oceans, no. Systems are protected inside of basically containment. It's a barrier, and the water that cools the core is all enclosed in piping systems and things of that nature. So as far as nuclear power being able to do something for the ocean, I'm not sure. Maybe you could be somebody that could figure it out. There's talk about harnessing wave energy to produce more electricity. So there you go. You could look for other avenues.
That's a really good question, because I think all of us up here have been around in the nuclear industry for a number of years, and the environmental side of it is very, very important to all of us. One of the things that we're dealing with at Hanford right now is a huge environmental cleanup from years of nuclear weapons production, and we're making huge progress on that. But as far as nuclear power plants, if you really look at the safety statistics and the environmental problems that they cause, it's very, very minimal. And so even the one that we saw in the news here lately on Fukushima and all the devastation and destruction and so on and so forth, the majority of the problem there and the deaths there were caused by the tidal waves and the earthquake. Nothing related to the nuclear problem with the reactors. So it's a really good question. As we plan forward, as we move forward with nuclear power, I think we all have to make sure that the environment's protected.
And if I could add to that a little bit too, the design of the plants and stuff, when the new designs come out, you're probably familiar with the process of environmental impact statements. They're very in-depth studies that have to be done with respect to actual damage to the ocean in terms of temperature changes and that sort of thing. There are environmental regulations that are involved, maximum temperature gradients you're allowed to impose in the ocean as a result of dumping exhaust heat into the water and that sort of thing. So there's a lot of engineering study that goes into it with the specific focus of making sure that we're not harming the environment with the things that we're doing.
Any other questions? Okay, if you,
Can I add one thing?
Please.
These folks have done a great job. Hi, I'm Ted Giltz. I'm the health physics manager at the Hammer Training Center. But the panel has done a super job of describing what some of the jobs are and what it takes to be in the jobs. One thing I want to emphasize, and this is key to all the young people in this room right now, is you're going to be making life decisions as you go forward for the next 4 or 5 years. And the nuclear industry has a commitment to the public, and the appropriate commitment to the public to operate safely and to have highly reliable people operating these plants in the different configurations that we do. That means that every one of you that goes into the nuclear industry is going to have to get through a basic security review. And if you get into other positions, you're going to have higher level security reviews. And if you want to proceed on, I guarantee you'll get scrutinized very heavily as you move forward. So as you are making decisions in your life and you move forward, that the DWI, the different things that happen to different people, you don't want it to happen to you if you want to get involved with this industry. Because if you do, you at a minimum will be prohibited for getting into it for a period of time, 5 to 7 years at a minimum normally, or prohibited completely just because you got it on your record. So keep that in mind as you're making those kinds of decisions and moving forward.
Thank you so much. That is so true. So make good decisions. Any other questions or comments? Okay, I'm going to wrap up. And again, thank you, panelists, for being here and imparting all your knowledge. To everyone here.